Most IT pros fail. Domain 2 because they confuse one critical pair of concepts. Here's how to avoid that trap before you even open the console. Let's set the stage. Open AWS Bedrock and request model access now, because later we'll be building with real models. The AI models behind popular chatbots are often built on transformers running in the cloud. AWS powers many of them. And Domain 2 of the AIF-C01 exam expects you to know how. If you've been following parts 1 and 2, you've built the foundation. Now we're cracking open transformers, LLMs, diffusion, GANs, and prompt design. All make or break for the exam. The exam loves to ask, which approach needs labeled data? Classical ML. Think discriminative models that map inputs to labels like spam filters. Generative AI learns the entire data distribution and creates something new. If a model draws a brand new cat instead of just labeling one, that's generative. Tokens are the smallest units LLMs process. And for AWS Bedrock, pricing is tied to token usage, so understanding them matters. Domain 2 is hard, becomes just a handful of tokens in GPT-4's tokenizer. You can check that right now on OpenAI's tokenizer page to see exactly how many. The exam expects you to know that subword tokenization like byte pair encoding handles unseen words gracefully. Embeddings? Map tokens into dense vectors where similar words cluster. AWS Titan. Embeddings models produce vectors with thousands of dimensions. Exact counts vary by model and version. Check current AWS documentation for the specific dimensions. King, man, plus woman, queen remains the classic exam example. Context windows vary widely among models. Instead of memorizing specific numbers, the exam expects you to match approximate model capabilities to tasks. Know the ranges and verify current limits in AWS documentation before test day. Before 2017, RNNs read text one token at a time, slow and forgetful. The Transformer paper introduced self-attention, processing all tokens in parallel. Remember this for the exam. Transformers unlock GPT and BERT by ditching recurrence entirely. Encoder models like BERT read the whole input at once, great for understanding. Decoder models like GPT generate one token at a time. The classic exam trap. Full translation uses both encoder and decoder. Many generative models, including ChatGPT, are decoder only, so you'll see that as an exam question. Self-attention transforms every token into 3 vectors: query, key, value, then computes how relevant each token is to every other token. This is how the model figures out that it refers to the cat, even across a long sentence. To see self-attention in action, open the Transformer Explainer from poloclub.github.io and trace the query key paths on a real sentence. These 4 steps are the engine of every LLM: matrix multiply, scale, mask, softmax. A common mistake: thinking the scaling factor is optional. It's not. Skipping it can lead to training instability, and the exam loves to test that detail. Multi-head attention runs several attention mechanisms in parallel. BERT uses about 12, GPT-3 uses dozens, up to 96. Each head specializes. One catches syntax, another co-reference. The exam may ask, why multi-head? Because a single head can't capture all the diverse relationships in language. Attention alone doesn't know word order. Positional encoding adds sine and cosine waves of different frequencies directly to the embeddings. So, the sky is blue, and blue is the sky, get different representations. The exam loves to trick you. These encodings are added, not concatenated. After attention, every token goes through a point-wise feed-forward network, 2 linear layers with ReLU, then add and layer normalize. Those residual skip connections keep gradients healthy. In GPT-3, this sublayer stack repeats about 96 times. The FFN introduces the non-linearity that makes the model powerful. Token IDs feed into embedding plus positional encoding, then through N encoder layers, attention plus FFN, and N decoder layers, masked attention, cross-attention, FFN. Finally, a linear plus softmax outputs probabilities for every word, the blueprint behind all generative architectures. Draw this pipeline on a whiteboard, label each block, and explain it aloud to solidify the blueprint. What makes an LLM large? Parameter count. GPT-2 had around 1.5 billion. GPT-3 scaled to roughly 175 billion. Llama 2's largest variant has about 70 billion, and Palm approaches 540 billion. Scaling laws show more compute, data, and parameters improve performance. A likely exam question on emergent abilities. The GPT lineage. GPT-1 started with around 120 million parameters in 2018. GPT-2's 1.5 billion made OpenAI nervous about misuse. GPT-3's 175 billion cracked few-shot learning wide open, and GPT-4 added vision, accepting images alongside text, a major shift from text-only predecessors. Claude's constitutional AI pipeline, train-based model, applies safety principles, self-critique, refine outputs. The result? A model like Claude 3 Opus, with a context window capable of handling large documents, available via AWS Bedrock. On the exam, reach for Claude when you need safe, long document reasoning. Meta's Llama models come in various parameter sizes, from billions to tens of billions, all decoder-only and released with open weights. They're fine-tuned for dialogue and run on SageMaker. For exam scenarios asking about an air-gapped private chatbot, Llama is your go-to. Quick comparison. GPT-4 and Claude are both proprietary, can handle text and images, and offer generous context windows. Llama stands apart with its open weights license. Deploy it on premises or in a VPC without sending data to an API. When the exam asks which model for a private chatbot, reach for Llama. Auto-regressive generation in action. Give the model the sky, it predicts is. Feed back the sky is, and it predicts blue. One token at a time. Use top K to keep only the K most likely next tokens, and top P, nucleus sampling, to grab the smallest set that sums to a probability threshold. The exam's favorite parameter question? Which controls randomness? Temperature. Your creative steering wheel in Bedrock Playground. Set temperature to 0 for deterministic answers, under 1 for precision, over 1 for wild creativity. Combine with top p-bow 0.9 to limit the token pool to the most likely 90%. Just remember, cranking temperature when you need facts turns your model into a confident liar. Prompt engineering is about detail. Write about AI gets a meandering essay. Specify bullet points, audience, and word count, and you get exactly what you asked for. Amazon Lex prompts follow the same rule. Precision always wins. Zero shot is the free lunch, great for everyday tasks. When you need reliable output on a narrow job, a few examples in the prompt, few shot, can lift accuracy dramatically. The exam expects you to know when to reach for each, and AWS Bedrock makes it 2 extra lines in your JSON. Chain of thought prompts the model to verbalize its reasoning. Just adding, let's think step by step to a math question can slash error rates. And the AIF-C01 exam loves to ask which technique improves arithmetic accuracy. Pre-training is a massive next token prediction game. GPT-3 gobbled the entire Common Crawl, burned millions of dollars in compute, and came out knowing grammar, trivia, and even some reasoning. This is the foundation. Expensive, unsupervised, and one-shot. Think of pre-training as a college degree. Broad and expensive. Fine-tuning is a specialized certification. Cheap, targeted, and ready for production. AWS Bedrock lets you fine-tune a base model on your own curated dataset, like medical dialogues, to build a health chatbot in days. PEFT methods like LoRa let you fine-tune a model on a single GPU. Freeze the base, train tiny adapters. On AWS SageMaker, LoRa can dramatically lower costs. The exam always tests this. You have a tight GPU budget. Answer, LoRa. RLHF is how ChatGPT learned to be polite. Humans rank outputs. A reward model captures good, and proximal policy optimization nudges the model towards safe, helpful replies. Exam question. How do you reduce harmful output? The answer is RLHF. Diffusion models destroy an image with noise, then learn to reverse the process. Start with static, and after 50 denoising steps guided by your text prompt, you get a coherent picture. Stable diffusion works exactly this way. To see it for yourself, try a stable diffusion demo on Hugging Face spaces and count the denoising steps. The UNet inside a diffusion model is an encoder-decoder with skip connections that pass fine spatial detail directly from the downsampling layers to the upsampling layers. This stops the denoising step from losing edges and textures. Without them, you get blurry blobs. Open a Colab notebook that visualizes the UNet denoising process and watch how skip connections preserve edges in real time. Clip turns your words into vectors, cross-attention layers inject them into the UNet, and the denoising process sculpts the static toward your prompt. Skip the prompt? You get a lovely patch of noise. Try it yourself in minutes via AWS Bedrock Jumpstart. Here's a number to jolt you back awake. Pre-training a large model can cost millions of dollars, but fine-tuning that same model on your own data can cost dramatically less, often just a fraction of the original cost. That massive gap is exactly the exam trap. They'll try to get you to rebuild from scratch when you don't need to. Now, let's compare two diffusion-based text-to-image models. On the left, Stable Diffusion, open source, runs on a SageMaker GPU instance for a few dollars an hour. On the right, DALL-E 3, proprietary, costing a few cents per image through API. The exam may ask which is cheaper to run on AWS. Stable Diffusion on SageMaker usually wins. GANs work like a cop and a counterfeiter. The generator makes fake images from noise. The discriminator tries to tell them apart from real ones. The adversarial loss forces both to improve. A known failure, mode collapse, happens when the generator learns just one trick and the discriminator can't push it further. Visit thispersondoesnoteexist.com to see GAN output in real time and observe potential mode collapse patterns. Here's where most test takers get it wrong. They pick GAN for every image generation scenario. On the AWS AIF-C01 exam, diffusion models handle high fidelity, diverse outputs. GANs are for pure speed. GANs deliver images in milliseconds, perfect for real-time style transfer. Diffusion models are slower, but give you richer variety and quality. Want to feel the difference? Spend 10 minutes trying both a GAN and a diffusion model on Amazon Bedrock's Playground. Watch latency and output quality side by side. Most common exam mistake: thinking cycle GAN requires paired data. It doesn't. That's pix-to-pix. Conditional GANs feed a label, like cat, to both generator and discriminator. This drives image-to-image translation. Pix-to-pix uses paired data. Cycle GAN handles unpaired. These are real exam examples for domain adaptation and sketch-to-photo tasks. Pull up a Pix-to-Pix demo on GitHub this week to see the difference between paired and unpaired in action. VAEs aren't as flashy as GANs or diffusion, but the AIF-C01 may ask about latent space smoothness. The encoder outputs a distribution, not a single point, giving continuous, interpolatable codes. You can train a VAE on SageMaker using your own TensorFlow or PyTorch script. The training job launch is straightforward from the console. Spend 20 minutes running a VAE training job to see how latent space interpolation generates new, plausible samples. The number one transformer concept test takers miss is cross-attention. It's the bridge between source and target. The original transformer was a seq-to-seq model for translation. The encoder uses self-attention on the input. The decoder then uses cross-attention to look at the encoder's output. Modern translation services like AWS Translate are built on similar principles. Open the console and paste a paragraph to see it in action. Multimodal models are the frontier. Clip aligns image and text embeddings. GPT-4v can reason about visual inputs. For the AIF-C01, a classic scenario is, a retailer wants to generate product descriptions from photos. The answer is using Bedrock with Titan multimodal embeddings and a language model. Try it yourself. In the Bedrock console, select Titan multimodal embeddings and test with a sample image to see the matching. Foundation model is the exam's favorite phrase. It means a large pre-trained model you can fine-tune or prompt for many tasks. Bedrock is the serverless gateway to FMs like Claude 3, Llama 3, and Cohere Command R+. This week, log into Bedrock, select any foundation model, and run a simple prompt. That's the entire workflow in 10 minutes. Commit this to memory. Foundation model, Bedrock. Bedrock is serverless, pay-per-token, and gives you access to AI-21 Labs, Anthropic, Cohere, Meta, and Stability AI models without managing infrastructure. Real step. Open the AWS console, search Bedrock, click Model Access, and request access to the providers you need. That's it. No clusters to spin up, and you can be running an LLM in under 5 minutes. SageMaker is for when you need full control. Start in Studio, grab a model from Jumpstart, fine-tune with LoRa on your own data, deploy to an endpoint, and attach a model card for auditing. The exam's rule of thumb: Bedrock for ready-made APIs, SageMaker for custom model work. A 10-minute spin-up in Jumpstart this week will make that distinction stick. Amazon Q Developer, formerly Code Whisperer, is a coding companion that suggests entire functions from natural language comments and scans for security vulnerabilities. Install the AWS Toolkit and try it in 5 minutes. Write fetch user data and watch the suggestion appear in your IDE. Lex supports multiple languages and lets you create a bot in the console with zero code. Rekognition's image labeling can drastically reduce manual review. To lock this into memory, create a Lex bot from the book trip blueprint in under 10 minutes. It's a hands-on way to memorize its role for the AIF-C01. Titan models are AWS's own foundation models inside Bedrock. Titan embeddings map phrases to vectors. Open the Bedrock playground and cluster dog and puppy to see it. Here's a gotcha. Most candidates miss. Titan image. Generator can include watermarks that are resilient to many common edits, and the exam loves that because candidates often assume watermarking is only for text. This week, drag a few phrases into the Embedding Similarity tool and watch the cosine distances light up. RagGrounds answers in facts. Embed the query, pull the top 5 relevant docs from OpenSearch, stuff them into the prompt, then let the LLM answer. It's simple, but here's a wake-up stat. Studies show RAG can significantly reduce hallucinations compared to a raw model, yet many beginners still assume fine-tuning alone fixes hallucinations. Bedrock Knowledge Bases automates this pipeline. Try it in 10 minutes and see how few hallucinations your own assistant produces. A chatbot talks. An agent does. Industry analysts predict a growing share of enterprise applications will incorporate agentic AI, so this is the direction. Bedrock agents orchestrate multi-step tasks. Book a table, update a DynamoDB table, send the confirmation. Exam gotcha. If the question involves calling an external API or writing data, it's an agent, not a chatbot. Try the AWS Agent Workshop. Build a flight booking bot in under an hour, and you'll never confuse the two again. Blue checks n-gram overlap, but many test takers don't realize its pure precision. A 3-word answer can score 100% while being wrong. That's why Rouge L adds recall, and the exam hammers this. If the scenario is a coherent medical summary, you choose Rouge L, not blue. For your own projects, load Hugging Face's Evaluate library and compute both in a notebook. The hands-on switch will save you on exam day. Real data is messy and compliance-heavy. Synthetic data, generated by GANs or diffusion models, can significantly reduce costs. Use AWS services like SageMaker to spin up synthetic fraud data in minutes. Same statistical patterns, 0 PII. LLMs predict the most likely next word, not facts. That's why Sally Ride sounds right, even though it's false. Hallucination is probability, not malice. To tame it, set temperature .xmu for deterministic output, use RAG, or fine-tune unverified data. Models mirror their data. A stable diffusion prompt for CEO overwhelmingly returns white male images if the dataset is skewed. Fix it. Use SageMaker. Clarify to surface bias, then diversify data and evaluate fairness. This is exactly the kind of real-world risk the AIF-C01 expects you to spot. For transformers, attention heat maps show exactly which input tokens drove the generation. Grab a Hugging Face model and launch BERTviz to see it in a browser. AWS model cards go even further by documenting intended use, performance benchmarks, and other critical details so you're never guessing about a model's blind spots. That's already enough depth for the AIF-C01. The exam will test you on these 6 AWS responsible AI dimensions: fairness, explainability, privacy and security, robustness, governance, and transparency. Example scenario: a bank's credit scoring model systematically denies loans to certain zip codes. Which principle is violated? Fairness, because protected attributes are causing discrimination. Memorize these 6 pillars. They always show up in some multiple-choice twist. Prompt injection is a real exam topic. An attacker embeds hidden commands inside a user prompt to hijack the model. AWS Bedrock. Guardrails help you set up content filters, like profanity and PII, that can block many injection attempts before they reach the foundation model. In the console, it's just a few clicks. Go try it. The cost difference is brutal. Pre-training a large model can cost hundreds of thousands, while fine-tuning an existing foundation model is orders of magnitude less expensive. A single API prompt call costs pennies. If the exam asks you to adapt an LLM with only 500 domain-specific examples, the answer is fine-tuning, never pre-training. Real Bedrock pricing reflects this exact spectrum. Use the AWS pricing calculator to estimate your own fine-tuning jobs before you get surprised. These 5 traps appear on almost every practice test. Print this list and stick it on your wall. Misunderstanding fine-tuning versus pre-training is one of the most common and costly mistakes on the exam. Watch for confusing fine-tuning with pre-training, exceeding token limits, temperature misuse, encoder-decoder confusion, and treating RAG as a pure LLM. Don't just read, build. Spend 20 minutes a day coding a simple transformer from scratch using PyTorch and the Hugging Face course. By exam day, you'll have a 5-layer model that actually generates text, and the multi-head attention will finally click. Right now, open the Bedrock console. Request access to Claude, then head to the playground and type this system prompt. You are an IT career coach helping beginners land cloud jobs. Try it. This exercise uses minimal API credits, so it won't cost you anything meaningful, and it will get you comfortable with the exact interface the exam expects you to know. The magic is under 10 lines of Python. In a SageMaker notebook, you load Llama 2 from Jumpstart, wrap it with PEFT, attach LoRa adapters, train on your own Q&A dataset, and deploy. This hands-on lab makes the fine-tuning concept exam-ready, and you'll actually understand what low-rank adaptation does. Pause the video and tackle this one. Self-testing substantially boosts retention, so don't skip it. The exam loves to blur fine-tuning with pre-training. Context windows are growing exponentially. Back in 2018, models handled a small context, often only capable of processing a short paragraph. Today, models like Claude 3 handle up to 200,000 tokens, roughly 150,000 words, or over 500 pages. On the exam, you'll be asked to match document length to an appropriate model. This timeline is your cheat sheet. Poly uses generative AI for speech synthesis. The exam may ask how to generate synthetic speech for accessibility. Know that Poly offers both standard and neural voices. Neural voices provide improved naturalness and are well-suited for applications requiring lifelike voice. You can call Poly directly from a Lambda function hooked up to Bedrock. Latent diffusion models like Stable Diffusion use a VAE to compress input images into a compact latent space, often several times smaller, so the diffusion model denoises in a fraction of the time, cutting training cost by an order of magnitude. Terms like latent diffusion will show up on the AIF-C01, so remember, compress first, then denoise. If you want to see this firsthand, open a stable diffusion pipeline in a Colab notebook and print the VAE encoder output shape. You'll literally watch compression in action. When you ask RAG to find documents similar to this query, a vector database like Amazon OpenSearch with KNN index compares embeddings, not keywords, and returns the top matches in milliseconds, handling high-throughput semantic searches with low latency. That's the core of semantic search, and it's directly tested on the exam. To experience this yourself, spin up an Amazon OpenSearch serverless collection with a KNN index, ingest a few sample documents, and run a semantic search. You'll be amazed how embeddings beat keyword matching. Knowledge distillation lets a compact student model mimic a large teacher. For instance, Distilbert reaches 97% of BERT base accuracy with 40% fewer parameters. Weight pruning removes near-zero connections without hurting performance. AWS Inferentia delivers cost-efficient inference. On the exam, expect to pick the right chip for optimized inference workloads. Secure your generative AI workloads with IAM policies that restrict model access. Route calls through VPC interface endpoints to keep data off the public web, and enable AWS CloudTrail so you know who invoked what and when. A classic exam question: which service logs API activity? The answer is CloudTrail. Domain 2 in one breath. Transformers. Decoder-only LLMs. Generation models and prompt engineering. On AWS, know Bedrock versus SageMaker versus Code Whisperer. Nail these 5 and you're exam ready. Next up, Part 4 dives into Domain 3, Foundation Models and AWS Services. Concrete tip: use Bedrock's built-in model evaluation to compare outputs from Titan versus Claude before you commit. Saves weeks of trial. Hit subscribe to catch it. Grab the official AWS AIF-C01 exam guide linked in the description, set a 4-week study calendar, and rewatch Domain 1 to fill any gaps. Run the free Bedrock hands-on labs to cement these concepts before you tackle Domain 3. Before you go, test your Domain 2 knowledge with a free timed practice exam at tutorialsdojo.com. Just search AWS AIF-C01 free practice exam. Then click the thumbnails to revisit Part 1 or Part 2 and subscribe to lock in the rest of this Zero Fluff series.